Hello everyone and welcome back. I am Mr. Kowalt, and in today's video I am going to be talking about the law of definite proportions. Now in the last video I think I misspoke regarding the name of this law. I think I said the law of direct proportions or something like that, but this is the law of definite proportions. So in the last video I was talking about the law of conservation of mass. And this is all in the context of the atomic theory. So let me just explain again the difference between a law and a theory. The laws are statements, general statements of what we see, what we observe in the world around us. Theories explain what we observe. So here we are setting ourselves up to see how the atomic theory can explain the laws, these observations. So in the last video, I was talking about the law of conservation of mass and how the atomic theory is consistent with what we observe. And so today we're going to be talking about the law of definite proportions. And definite means is another word for constant. So the law of constant proportions. This is a law that was formulated by a chemist, another French scientist, Joseph Proust, 1797. And what he observed was that all samples of a given compound, regardless of where you get them, regardless of how they were made, they're all going to have the same proportions of their constituent elements. So what does that mean? That means that if I break down a substance into its elements and I know their masses, then the ratio or the proportion, that's another word for proportion, is a ratio. The ratio of their masses is going to be the same for that particular compound, no matter where I get it. So here's a couple of examples. So if I have 18 grams of water, I can break that down into oxygen and carbon and hydrogen using a process called electrolysis. So I can run electricity through water, and I can get hydrogen and oxygen gas. So if I do that with 18 grams of water, and I break that down into 16 grams, I'll get 16 grams of oxygen and 2 grams of hydrogen gas. And so you can see again that this is consistent with the law of constant conservation of mass, right? So I have 18 grams here, I have 16 and 2. So again, we're obeying the law of conservation of mass. But in this video, we're focusing on the ratio of the constituents of the substance, in this case, water. So if I take the masses of their constituents and I put them in a ratio, so I get a mass ratio, in this case 16 grams of oxygen over 2 grams of hydrogen, then that's going to come to an 8-to-1 ratio. And that ratio, that proportion of the constituent elements, is going to be the same ratio no matter where I get my water. So as long as it's pure water, no matter where I got it, no matter how I made it, it doesn't matter if I find the water on Mars or the water, on Pluto, wherever I find water. If it's pure water, then the ratio of the constituents is always going to be the same. Same thing regarding ammonia. So if I have 17 grams of ammonia, that's going to break down into 14 grams of nitrogen, 3 grams of hydrogen. Again, if I get the mass ratio of the constituents, in this case nitrogen and hydrogen, so that nitrogen and hydrogen make up ammonia, then here I don't get a nice round number, I get 14.7 over 1. So again, no matter where I get my ammonia, no matter where or how I make the ammonia, the ratio is always going to be 4.7 to 1. And so that is what we mean by the law of definite proportions. Definite, again, meaning constant. the law of constant proportion. Proportion is always the same between the elements that we find in our compound. Now, again, how does the theory of the atomic theory relate to this? Well, this is something that we would expect if things are made out of atoms. So if you can see here that if a compound such as water is always made out of the same number of atoms, 2 to 1, right? So I have 2 hydrogens to 1 oxygen. If that is always the same, then we would expect that the mass proportions are going to be the same as well, right? So finding the constant proportion between the masses of the elements is consistent with this idea that our compounds are made up of atoms, and the same compound is always going to be made up of the same types of atoms in the same ratio, right? So here we always have a 2 to 1 ratio regarding the number of atoms making up water. So we would expect that the ratio of the masses are always going to be the same as well. And we can see that we have a 1 to 3 ratio regarding the number of atoms of nitrogen and hydrogen. So because that ratio is always going to be the same according to atomic theory, we would expect the mass ratio to always be the same. So again, the atomic theory is a way to explain these observations, okay? I hope this was helpful, and I hope you got a lot out of it. And if you like this video, share this video, like the video, make a comment in the comment section if you want me to go over anything else, and ring the bell. Thank you, and see you next time.